Hello, student. Let's try to understand the exercise problem of the coordination. Already, I told you to discuss this problem ever before. So let's try to solve some of the problem. Here you see the question number 1. Or else let me check that sharing, students, where we can do the sharing. There, this is the screen sharing is there. Let me check. Oh, this is not the correct one or not. This is the Microsoft Edge now. Yeah. So this is the question number first, student. What the question number first? Explain the bonding and coordination compound in terms of the Werner postulates. So what the Werner postulates here is, student, this is the Werner was the first person who gave the detailed information about the bonding and coordination compound. And that is why he is also known as father of the coordination compound. Who is known as father of coordination compound? That is Werner is known as father of the coordination compound. Now, if you talk about the bonding and coordination compound, here you see, student, bonding and coordination compound. So there are two types of valency are there, student. One is the primary valency, and second one is the secondary valency. That you need to understand. Secondary valency. Now, student, what is the primary valency? This valency is ionizable. This is the ionizable. And secondary valency, non-ionizable. Non-ionizable. Now, primarily valency satisfied by, how, student? Satisfied by counter ion. This is satisfied by counter ion. And secondary valency by coordination number. This is the satisfied by coordination number. Okay. Now, if you see counter ion means that is ionizable, represent oxidation number. It is going to represent what, student? Represent oxidation number. This is the oxidation number. And secondary valency represent what is the, student? It is representing represent the coordination number or number of lone pair electron donated. Lone pair electron donated. This is what the concept is, student. How you are representing the primary valency, student? Represented by dotted line. Represented by dotted line. You are a dotted line. You are saying this is how you are representing single dash line. You are representing this one secondary valency. Single dashed line. This is. Now, in many cases, student, what you are going to find here, that is the compound may have primary and secondary valency both. Compound may have primary and secondary valency both. Then in that case, what you are going to do, student? In that case, what you are going? In that case, you are representing both the form. Suppose we are having the FeCN 6, student. And here is the, we are representing Cl2. So here is what is there, student? This is the counter ion. Counter ion. This is the counter ion. Representing what, student? Primary valency. This is going to represent primary valency. And this is inside, this is the ligand. This is the ligands. And this is representing what, student? Secondary valency. This is going to represent secondary valency. Now, students, why I am saying primary valency is ionizable? If you see, student, if you see this one, so it will give two type of complex. FeCN6. On this one, it will be, suppose how much charge it can be, student? That is 2 plus and 2 Cl minus. So counter ion ionizable, that become the primary valency. And this become the secondary valency. What will be the structure, student? Fe. This you see. These are there. So 6 valencies are there. Here is one cyanide ion. Here is another CN. This is the CN. Here is the CN. Okay. And what is this? This is the total 6 CN are there. So we are representing this by solid line. So if you are representing this by solid line, so what it does explain, student? This solid line is saying the secondary valency. This is the secondary valency. And what about the primary valency? Primary valency you can mention by the dash line, student, somewhere here. Right. So this is all about the Werner theory, dear student. Okay. What we are going to do here now, let us try to get some idea about the other questions. Question number next we are moving. Let us see what is the question number next. Here we are getting the question number next, student. Let me tell you the question number next. Let me close the gate first. So now you see, student, if you talk about the question number 2, these are also very simple question, student. Very, very simple question. So they are saying FeSO4 solution mixed with NH4 twice SO4. So here is FeSO4 is there. You are heating this one mixing with NH4 twice SO4. So it is 1:1, student, right? Molar ratio, the taste of 1:1 molar ratio give the taste of Fe2 plus ion. It is giving the taste of what, student? Fe2 plus ion. If you see this one. So if it is giving the taste of Fe2 plus ion, it means it is not going to form the coordination salt, student. It is not going to form the coordination salt, means it is going to form the double salt. So it will be the what, student? FeSO4 dot NH4 twice. It is going to be SO4, student, dot 6H2O. So this is called, student, Mohr salt. Mohr salt. And it is having all type of ion. If you ionize, it will give Fe2 plus ion, student. Plus it will give what, student? SO4 2 minus. Plus it is going to give NH4 plus ion. This is what? NH4 plus ion. So this all things you are going to get to know, student. So since it is giving what, student? Fe2 plus ion, give the positive taste of the Fe2 plus. Gives positive taste of Fe2 plus. Fe2 plus. Okay. Now, here you are see, student, another one. If you are treating FeSO4, student, FeSO4, and with the, but CuSO4, here is CuSO4 mixed with the 1:4 molar does not give the taste of copper 2 plus ion, right? So what it is going to give, student, it will give the complex. It is going to give the complex. Let us see what the complex is going to be. Okay. So if you are mixing in this one, student, in this ratio, so what you will get, that is Cu. It will be the, here is the solution is SO4. Let us take the SO4 itself in spite of taking. Okay. CuSO4. How many times, student? 4 times. This is. And here is the, you read one the question, student. FeSO4 solution mixed with this one ratio give the taste of Cu, but with copper sulfate aqueous ammonia. Aqueous ammonia also you are taking, student. Sorry, this is the copper sulfate is there. And this is not there, this one. Okay. Which one is there? Aqueous NH3 is there. Aqueous NH3. So what the complex you are going to get, student? CuNH3. This is the CuNH3. This is how many? 4 times, student. And this is going to be the 2 plus. And in this case, no Fe2 plus, no Fe2 plus test. Why? As what, student? it is not ionizable. It is not ionizable. Okay. This is going to give the complex with the copper as ion student. FeSO4 mixed with NH4 is give the taste of FeSO. But CuSO4 mixed with aqueous ammonia, CuSO4 aqueous ammonia does not give the taste of copper. It is not going to give the taste of copper, not iron here. Copper. Why? Because it's non-ionizable. What is meaning, student? Square bracket, what we are having, square brackets cannot be ionized. Can't be ionized. So if you want to ionize, can't be ionized. So does not give, student. Does not give taste of what? Give taste of Cu2 plus ion. So this is our required answer. I hope it will be clear to you. Now let us move on to the next question. What is this question number 3? Question number 3. Explain with the 2 example each of the following coordination entities. First one, ligands. Second one, coordination number, coordination polyhedra, homoleptic, heteroleptic. These are the there, student. Coordination entities is what, student? Whatever they are in the square bracket, student. Okay. Species in square bracket. Species in square bracket. Square brackets called, student, what it is going to call? Coordination entities. Coordination entities. Entities. Like, suppose if we are having FeCN6 student, and that is 2 plus. So this is what is called, student. This is called coordination entities. Coordination entities. Next one, ligands. Ligands. What do you mean by ligands, student? If you talk about ligands, ligands, they are lone pair donor, lone pair donor, lone pair donor to the central metal atom, to the central metal atom. This is what is called ligand. Now, student, if I talk to you, this one, suppose Cu Cn 6 time is there, and here is 3 plus, suppose. So what we are going to have, student, see this one. Cn is there, it transferred the electron. Cn, it also transferred the lone pair electron. It is also transferring lone pair electron. This is also transferring lone pair electron. This is also transferring lone pair electron. So this is, here you see, student, this one. So what is happening, student? This all, whatever the species we mentioned here now, this one, they are going to represent, since they are the donating the lone pair electron. So they are what is called, student. This is called the ligand, student. This is our required answer. So ligands are the lone pair. Ligands can be, student, that is the monodentate. You can say monodentate. What is monodentate? Donate one lone pair electron. Donate one lone pair electron, LP electron. Didentate or bidentate. Bidentate means donate how many pair electron? Donate two lone pair electron, student, two LP electron. Polydentate, student, polydentate. So polydentate means more than two lone pair. More than how many, student? Two lone pair electron. It is going to donate more than two lone pair. Now you see what is the next one we are having, student. Coordination polyhedron. Okay. So coordination polyhedron. This also asked in the exam, student. Coordination polyhedron. Polyhedron. Now, dear student, you see coordination polyhedron. What it can do is, dear student, that is, it is arrangement. What, student? It is arrangement of ligands. Arrangement of ligands around central metal atom. Central metal atom. Now, students, here you see. That is the, here we are writing the compound. Which compound, student? Coordination compound. And here is a hybridization. Hybridization. Okay. And here is coordination polyhedron. Coordination going to be polyhedron. Simple, you can also write, student, shape. That is also correct one, student. Suppose we are having, dear student, NiCN. This is a 4. This is going to be, here if you are mentioning, student, that is -2. So here is quad. Hybridization is what is going to be, student, DsP2. Coordination polyhedron is a square planar. This is going to be square planar. Now, what another one? NiH2O. What is there, student? 4 times. Then here is 2 plus. So it is going to be sp3. So that is tetrahedral, student. This become the tetrahedral. Now move to that one, another one. So another one, if I am mentioning, student, CrNH3 6 times 3 plus. So in this case, it is going to be D2sp3, student. This is going to be octahedral. Coordination polyhedron is going to be octahedral. Another is also possible, student. CrCO 6 times. That is another going to be 3 plus. This is here in this case, not the CN, student. CU. This one you can put out to be Cl. So this will be, that is what? sp3d2, student. That is going to be octahedral, dear student. So this is all about the answer, dear student. That coordination polyhedron is arrangement of the rear end. Homoleptic and heteroleptic complex, student. What do you mean by homo and heteroleptic? So if you talk about the complexes, dear student, complexes, there are 2 types of complexes possible. The first one is called homoleptic. This is what is homoleptic. Another is what is this, student? Heteroleptic. What do you mean by homo? Means that's a very simple. That is same. Dear student, homo means same. If I will talk about hetero, it's going to be different. This is going to be different. If I will talk about leptic, leptic means ligand. If the ligand is same, student, if the ligand is same, so what will be there? Homoleptic. Same ligand, homoleptic. Different ligand, heteroleptic. Let us see with the, go with the example. Suppose FeCN6 you are taking, and here you can go with the 3 plus. So what is all same now? All 6 ligand, all same. All same ligand. So if all same ligand means it is going to be, dear student, homoleptic. Now another one you see, Fe NH3 4 times, then Cl, then NO2. So how many types are there? 3 types. 3 types of ligand. 3 types, got, student? 3 types ligand. So this is going to be what, student? That is heteroleptic. That is very simple, I think. You can be able to understand very simply. This is the all get over, student, whatever the terms are there. Okay. Now, let us move out the next one. What the next question? What is meant by unidentate? Unidentate, donate one lone pair. Donate one lone pair. Like what, student? NH3. Okay. It can be NH3. Then another, it can be H2O is also, although it is having the 2 lone pair, but it is unidentate only. Cl minus, F minus, Br minus, they are the unidentate. Didentate. Didentate. It can donate 2 lone pair electron, like oxalate ion. This is. So it can donate 2 lone pair electron. Ethylene diamine. So NH2, CH2, CH2, NH2. So it is donating the 2 lone pair now. So they are going to be didentate. Ambidentate. Ambidentate means it can have 2 linking atom like that, NO2. Okay, the linking with the nitrogen. ONO linking with the oxygen. Ambidentate. Like the NCS or SCN. So it can either linked with the nitrogen or linked with the sulfur. So this is what is the ambidentate. What else is there? Give two example of each. So that is bidentate. This is the oxalate ion. Oxalate ion. And that is IUPAC name is oxalato. Ethylene diamine. This is name is ethylene diamine. Right. This is nitrito N. This is nitrito O. Thiocyanate. Okay. Encina isothiocyanate N. Here is the what is their student? Thiocyanate. Thiocyanate. It is going to be what student? S. This is. Now, let us move to the next question, student. Specify the oxidation number of the metal in the following. So question number 5. You see, student, this is very, very simple question. So COH2O is there, student. Then it is CN there. Then En twice is there, student. And there is 2 positive charges there, dear student. So suppose we are considered to be X plus. Here is the H2O 0. Cn is -1 plus 0 multiplied by 2 equal to +2. So X is equal to +2 +1. So X is equal to +3. So oxidation number in first case, it is +3, student. Next one, we are having PtCl4 and that is 2 minus. So Pt, student, Pt. So we are considered to be X, 4 molecule, Cl is -1 equal to -2. So X minus 4 is equal to -2. X is equal to -2 plus 4. X is equal to +2. So nickel case, platinum case, it is +2. Fifth one, you see, CrNH3, how many thrice? And Cl3. See, student, NH3 is the 0 oxidation state. Here is the X, 3 molecule NH3 0 plus 3 molecule Cl, that is -1 equal to 0. So X plus 0 minus 3 equal to 0. So X is equal to +3. This is. Now let us check back to the next one, second one. What going to be second one, student? This is COBr2 En twice. And what is their student? Dear student, this is the positive. So here it is going to be X plus 2 minus 1, 2, 0 equal to +1. Because total charge here is +1. So X minus 2 equal to +1. So X is equal to +3. This is the second one. Now, let us move back to the next one. Question number, last one. K3FeCN6, student. Let's try to do this one. K3FeCN6, student. K3FeCN6. This is there. So this is the X, student. This is +1 multiplied by 3. 6 multiplied by -1 equal to 0. +3 plus X minus 6 is equal to 0. X is equal to 6 minus 3. X is equal to +3. So this is the oxidation number. I calculated all the. You can go and check back. Okay. Now let us move to the next one. Here it is very, very important question, student. Using the IUPAC norm, write the formula of the following compound. Tetrahydroxydozincate. We are going to first one. Tetra means 4. Hydroxydo means OH. Zincate, if I am writing zincate means what is Zn. ATE now, student, negative anion, negative. So that is what we can write, student. Zn OH 4 times. It should be the negative one. So how much negative ion we can put, student? So if you are putting -2, so the charge will come 2. You can calculate back. X plus 4 in bracket -1 equal to -2. So X minus 4 equal to -2. X is equal to -2 plus 4. X is equal to plus 2. So here, dear student, this is the absolutely correct answer. Okay, ZnOH 4 times 2 minus. Now we are going to potassium tetra. I'm erasing someone because it is taking the spaces now. So what we can do in spite of I think this screen is share. It seems that it is not share. I didn't check that anywhere. That is why. Wait a moment. Let me check that whether it is okay or not. We have to write the potassium, student. Second one now. Potassium means K. Tetrachlorido student. Tetrachlorido So so here is potassium is the K, that is K. Tetra, this is the potassium ion is will be outside. Tetrachlorido, Cl will be 4. Palladate second. So PD will be, but they are thinking it should be second. So what we have to do, you need to put simply the K2. Okay, this is what the name. Here you can consider to be X. Okay, if you are facing the confusion here, so we can do the calculation oxidation number. So if you are considered to be X plus 1 multiplied by 2, 4 multiplied by minus 1 equal to 0, plus 2 plus X minus 4 equal to 0. X is equal to 4 minus 2. X is equal to plus 2. So this is correct. Plus 2 is coming. Now the third one. Diamine. Dichlorido. Platinum second. Diamine. So NH3 it will be how many times, student? NH3 will be 2 times. Diamine. Dichlorido. Dichlorido means Cl2. Platinum second. So it is Plt. And here they are talking about the charges if you are talking about here. Platinum second. It should have the 2 charges, student. Platinum second. So here there will be no charge, student. Why? Because already 2 is there. And name is IUM, platinum is there, normal name. So it is neutral compound, charge 0. You can consider to be X. Then 0 multiplied by 2. 2 multiplied by minus 1 equal to 0. So X plus 0 minus 2 equal to 0. So X is equal to plus 2. So this is very simple, student. Potassium tetracyanide second. Now AT is there. So this is negative 1. So here you see K, that is potassium outside. Tetracyano, Cn will be how many times? 4 times. Tetracyano, nickelate, Ni, nickelate. Here is there. And that is negative charge should come. So what should we put here? So that it should give the negative charge, student. So if I will to put here minus 2. Not actually, potassium is there na. So in spite of putting here, what you can do, you can place here the 2 here. So let us see the what the you calculate this one. So if you are calculating, student, so it is going to give the X. I am considered to be the first one nickel oxidation number. You can consider X plus it will be 2 minus 4 equal to 0. So X is equal to 4 minus 2. So this is going to be give plus 2. So this is the correctly coming na potassium tetracyanide nickelate. This one is because when you ionize this one, 2K plus is going. So NiCN4, this will be the 2 minus. So there is no problem na ATE we can use here. So this is there. So total we have done the 4 one. So let us going to move out the 5 one. Let us check what it can be. Dear student, 5th one you see. Pentaamine. Pentaamine means NH3 should be 5 times. Nitrito O, that is NO2. O, and nitrito O means what? ONO. ONO. Cobalt third, CO. So cobalt third means this is going to be 2 plus. Now, you said, sir, cobalt 3 is there, and why you are mentioning 2? So you can calculate back it. How can you calculate, man? This is there, you see. You can find out x, then 0 multiply by 5, and here is plus 1 multiply by minus 1 equal to plus 2. So x plus 0 minus 1 equal to plus 2. So x is equal to plus 3. This is there. So fifth one is also finished. Now go for back to the sixth one. Hexaamine cobalt third sulfate. Hexaamine cobalt third sulfate. So cobalt is the center metal. NH3 is how many times? 6 times. And cobalt, that is what SO4 also you need to put. But here the C oxidation state is third. 3. It is not going to give 3. Because hexaamine cobalt third sulfate. If you are calculating, it will give plus 2. So what you can do? What you can do, student, in this case. So you need to multiply by this by 3. If you are this or multiply by, even if you multiply by 2, 3. So 3 to just 6 by 2 plus 3 it will give. This you multiply by 2 and this multiply by 3. See, this will going to give the 2x plus what will be there? 12 into 0. And here what will be there? Plus 3 minus 2 equal to 0. So 2x is equal 2x plus 0 minus 6 is equal to 0. 2x is equal to 6. X 6 by 2 going to be plus 3. So we get exactly plus 3. So here is this CuNH3 6 twice and SO4 it will be 3 times. Now let us move back and tell the 7 number. Potassium trioxalato. Next one we are going, student, what is there? Potassium trioxalato. Chromate third. Very simple, student. Potassium will be outside. Trioxalato. Trioxalato means OX. How many times? 3 times. Chromate. Cr. Third, it should be third. So 6, here it will be 3, student. Okay. So it will be, this is the name. Now you can say how 3 is coming. So it is x plus 3 minus 6 equal to 0. So x is equal to 6 minus 3. X is equal to plus 3. You will say why 8 is there? 8. If you ionize this one, so it is going to give 3K plus Cr OX 3 times. And here is going to be 3 minus. So this is negative charge, na? Negative charge. Negative coordination is sphere means ATE. Next one, student. Hexaamine platinum 4. Let us erase this one. And we are going to tell the next one. Okay. Next one is what is hexaamine platinum 4. Hexaamine, student. So that is NH3 how many times? 6 times. Platinum is there. And it should be, they are saying hexaamine platinum neutral, that is positively charged. So plus 4, there is no problem in this one. Hexaamine platinum 4. Next one, tetrabromo. B are going to be 4 times. Tetrabromo cuprate, Cu. They are saying you mentioned to be here plus 2. Okay, cuprate. Now you can ask student, why the sir, why you are putting plus 2? So you can calculate x 4 minus 1 equal to plus 2. So x minus 4 equal to plus 2. So x is, sorry student, it should not be plus 2. It actually, this is minus 2. Minus 2, I am extremely sorry. This is minus 2. Then only it can give. So minus 2 plus 4. So x is equal to, it is going to be plus 2. So this is exactly coming. Now the last one, let us move now. The 10th one. Okay. What it can be 10th one, student? Very easily you can do. Pentaamine. Pentaamine means NH3 5 times. Pentaamine. nitrito N. So NO2. Then it is cobalt going to be third. That is going to be 2 plus here. You can ask why cobalt third. So this is X. 5 NH3 is neutral molecule 0. NO2 is the -1 equal to +2. So X plus 0 -1 equal to +2. So X is equal to, it will be +3. So this is what the correct one. Now we can move the next question to see if any questions we can find out here to solve. Using the IUPAC norm, write the systematic name of the following they are asking. So first one, it is CuNH3. How many times are there, students? 6 times. And this is going to be Cl3. So this is what, student? Hexaamine. Hexaamine. What will be there, student? Hexaamine cobalt. Hexaamine cobalt. This is third chloride. Third chloride. Why, student, not cobaltate? Because it is the positive coordination of sphere. If you ionize this one, CONH3, how many times? 6 times. 3 plus 3 Cl minus. So since it is positive, so that is cobalt. Hexa means 6 is there. Amine means NH3. Chloride means Cl. So this is what the name. Now second one. This is what is there. PTNH3. This is going to be twice Cl. NH2CH3. This is Cl. So what is going to be name, student? This is the diamine. Diamine. 2 places chlorine is there. Dichlorido. Okay. Methyl amine. See the question once more. Cl is only one place, student. One Cl is outside of the square bracket. So we need to change this one. So here will be Cl. So in spite of mentioning diamine, it should be chlorido. Diamine, chlorido, methylamine. This is the methylamine. And what the platinum? No, platinum. What will be second chloride? This is the IUPAC name of the second one. If I will write the third one, what is their third one? TiH2O. This is the TiH2O. 6 times is there, student, and 3 plus is there on this one. So what is the, that is hexa aqua titanium. This is the third. So this is, so this way you can answer all the questions, student, if you are talking fourth one. So fourth one, what is there, student? This is the cobalt and NH3 4 times, student, Cl. This is NO2, and here is the Cl. Dear students, let's find out this one. So this will be the what, student? Tetraamine. That is the tetraamine. This is one thing is there. Then chlorido, nitrito, NITRITO, nitrito N. Then what will be there, student? Cobalt. Oxidation number is second chloride, student. This is the name. Here you can see this one. Yeah, this is correct only. Fourth one we have done. Fifth one also you can do, student. 6 is also easy. These all are easy. You try to do with yourself, student. And the remaining question, we'll try to finish it by tomorrow. Thank you, student.